Now we'll see about quasi-static process. Okay, quasi-static process means is a slow process. Okay, so in this system we have to maintain the thermal, chemical, and also mechanical equilibrium with the surroundings of the system. Okay, so consider a cylinder filled with ideal gas. So this is a gas region. This attached with the piston is a mover piston. So we can move up and down. Okay, so initially we have to note that the volume is a V, pressure is P, temperature is T of the ideal gas. Okay, when the piston is attached to the cylinder, it moves outward, so the volume of the gas will be changes, it will be increases. Okay, the piston is move upward means the volume will be increases of gas. As a result, the temperature and pressure will be changes, because volume is changes means its pressure and temperature also changes. Okay, then we know that gas law, gas equation, PV equal to mu RT. PV equal to mu RT. Pressure, volume is equal to mole, gas constant, and temperature. Okay, so if a block of some mass is kept on the piston, we place some mass on the block of the piston means what will happen, the piston it moves suddenly downward. Okay, so the pressure near the piston will be maximum than the other region. Okay, so in this case that we cannot find that pressure, volume, temperature at instant, because the piston will be moved fastly. So we have to slow the process. Clear? So if the piston is pushed very slowly downwards, okay, such that the every stage it is in still equilibrium with the surroundings, which means you can find out the pressure, volume, temperature of the system with the surroundings. Okay, so this kind of process is called quasi-static process. Okay, so really it is a slow process, so that it remains in thermal, mechanical, and chemical equilibrium with the surroundings throughout the system. Okay, so using this concept we have to find out the work done in the volume changes. Okay, so if the piston is move upwards means what will happen, we can find out the increased volume. Okay, but here we can using sand instead of the masses of the block. Okay, if adding sand slowly means the pistons move slowly downwards. So this is the example of the quasi-static process. Okay, now we will find out what is the work done in the volume changes. So now we have to find out the work done by the gas. So consider a cylinder filled with the gas. Okay, this is a piston. Now we have to move the piston is upwards by pushing slowly. The meaning of a quasi-static process. Okay, so the volume will be increased. Okay, so what is the distance moved by the piston in the gas means this dx is the distance moved in the gas region. Clear? So piston is moved upwards, the volume of gas is increased with the distance of dx. So using this constant you can find in the work done by the gas. So first we have to find the small work done by the gas if the piston is moved upwards. Okay, so the small work done by the gas, say dW. W is the symbol of work done, which D refers the small work done. Okay, formula F is W equal to F into dr. Now we will write as F into dx is the force exerted by the gas. Dx is distance moved by the gas as a volume. Okay, in the cylinder. Okay, so put the equation number 1. Now we have to find that force. Okay, the pressure formula. Pressure of gas P is equal to F by A, force by area. In this relation, what is F? The divided area of the material of pressure. So we can write F is equal to pressure into area. This is substitute in the above first equation. So we will get dW is equal to F. We can write as P into A. So P into A, then dx. The equation number 2. Okay, where F is come the force exerted by the gas on the piston. Okay, Now we have to find in that what is the area with the distance. Okay, we know that volume. If your piston is move upwards, the volume will be increased. Okay, so that volume formula we know in general is what L into B into H. So L into B we will write as area. H is called distance. This meaning of volume for the general formula. But here the volume increased by the gas. It will be changes, correct? So you put change in the volume is equal to area. So what is the increase of the piston in a gas cylinder means? That is a dx distance. I already shown the figure. So the dx is the distance moved by the piston by increasing the volume of gas. So you can write dv equal to a into dx. This is substitute in that second equation. So let us dw is equal to p. So a into dx we let as dv. So that the small change in work done is equal to pressure into the volume changes. Okay, put the equation number 3. Here the volume is being increased, no? So this is pressure is positive. Okay, so in general the volume will be changes from initial to the final volume. Okay, so we have to find in that entire work done. The volume change means put work done is equal to, so we have to integrate this small region of the work done. So put integral of dw, then we get w. At the same time we have to integrate in the right side also. So integrating of p into dv, then d is the changes here, p is constant. So the volume changes from infinity to initial to final. So va indicates initial volume of the gas at initial, vf is the final volume after increased. Okay, so we get w on the left side, on the right side p is constant, so take note of the integral. Then remaining we have vi vf into dv. You know that integration and differential both are cancelled to each other, so we have only v here. So v pressure into v. After integration we put that this value in the right side, the limits. So vf in vi. So it is not going to apply the upper limit minus lower limit. So we will get w is equal to p into vf minus vi. So this is the general formula for that work done in the volume changes. Okay, it's a very important formula, keep it in mind. So using this thing we can know that water will be positive or negative. Okay, first case, if the final volume of the system is increased greater than the initial volume, so vf is greater than vi, so it should be positive. Okay, so that work done will be positive. Same time the initial volume is greater than final volume, so vf is less than vi, then see vi means put minus, so the w become negative. Okay, so based upon the increase or decrease volume, the water will be positive or negative. That is done by the gas. Okay, this is a 3 mark question. Next we will see that the PV diagram is a very important concept. Okay, P stands for pressure, V stands for volume. Taken in V taken in x-axis, pressure taken in the y-axis of the graph. Okay, so PV diagram is used to calculate the amount of work done. Okay, is used to calculate the amount of work done by the gas during expansion and compression. Okay, first I will explain what we mean by expansion. So the expansion means the volume of the gas will be increased. Okay, due to the heat that given the temperature. So if the volume is increased, the pressure will be decreased. Okay, that is the meaning of expansion. In case of compression means pressure is increased, volume will be decreased. Clear? So the two possible things are happen in the gas while heating. Okay, which means the gas get that internal energy. Okay, it is increased means the volume will be increased, pressure will be decreased. This is called expansion. Okay, so the graph means, see, we draw for the expansion, which means pressure is what decreased, volume will be increased. So volume will be increased now. So we'll take in the here. It's initial. The point here is initial pressure and initial volume. Say PA VI. As per expansion is what pressure will be decreased. So pressure will be decreased, volume will be increased. So we get that graph like that. It shows the volume will be increases, the same time pressure will be decreases. So put the point here. It's called the final pressure and final volume. Okay. So using this curve, we can find out what is the work done. So you have to draw the area of the graph shows. Okay. The symbol is during the expansion. This is the area. So area of this region, this is called work done. Work done equal to area of the region where the limit of initial volume then final volume. No, initial volume, final volume. The formula for the work done we know P into dV. Okay. So this is a very important concept. It is used in Carnot engine theorem. We will study in later. Okay.